Hello everyone, I'm Yuxia Zhang, a PhD graduate from Peking University. Welcome to my presentation of our paper, How do companies collaborate in open source ecosystems? An empirical study of OpenStack. With a creative pattern of software development, open source software becomes important to software industry and our society, especially the larger ones such as the Linux kernel. A recent survey from Red Hat indicates that almost all information technology companies use open source in their productions. Commercial participation continues to grow in open source projects. Take OpenStack as an example. The number of companies involved each year shows a linear rising trend. Also, commercial involvement has made substantial contributions. As reported by 2017 annual report, companies contribute around 85% of code to the Linux kernel. And companies involved in the same open source ecosystems work with from different domains, such as hardware, network, and database. Collaboration among them with specific expertise may greatly benefit the development of open source. Otherwise, the companies work with want to realize their goals, and the same goals always bring intense competition. But we do not know how do companies work together. Unknown may bring risks or hide opportunities. Since we want to guarantee and the open source software ecosystems can sustainable development, especially those important ones, we need to know how all the pieces work together. Our research goal is divided into several research questions. First, we are interested in understanding how companies contribute to specific projects within the wider ecosystem. Further, we posit that a relationship may exist between companies if they work together on the same project, and we expect patterns to form. Lastly, prior research has suggested that collaboration may increase developer productivities. We want to know that it has the same effect on companies' productivity. Now, let's see how we conducted this study. We collected and cleaned the commit data of OpenStack for further analysis, including cleaning both merging duplicated identity and identifying developers' affiliations. We applied two-mode social network analysis to demonstrate that hundreds of companies contribute commits to about 1,000 projects in OpenStack. Then we obtained clusters by grouping together closely related nodes. Finally, we try to understand each cluster from two aspects: company's business strategy and the project's functions. As a result, we detected 32 clusters in the company project network based on the commits data produced in the development of 14th OpenStack release. The network has 150 company nodes and 817 project nodes. By explaining the core companies and the most common project categories in each cluster, we found 4 typical combinations of companies and projects. For example, companies holding the business integration strategy often contribute to plugins or drivers to integrate their own business with OpenStack. Other companies making profit through providing full solution based on OpenStack often contribute to the deployment tools. And the clusters centered on large information technology companies involves extensive companies and diverse projects. And companies that select specific projects to contribute to are driven by the particular business or focusing the business on the base of one project or incubating new service. By exploring the background of the pairs of companies that appeared in the same cluster and the functions of the project they contributed to jointly, we found 3 company collaboration patterns: intentional collaboration, passive collaboration, and isolated collaboration. And we also found the 3 sub-patterns in the intentional collaboration, such as supply and consumption, distribution-oriented ally, and service delegation. We can find that these companies, some collaboration are actively and intentionally pursued, while others are passive and incidental. By fitting regression models, we found a positive association between companies' collaboration degree and its productivity. Our work has rich practical implications. The 4 combinations of companies and projects offers a picture of how hundreds of companies participate in as many projects, forming an open source ecosystems that deliver a complex distribution in a limited time. The 3 collaboration patterns also uncovers companies' interactions in a complex open source ecosystem. Our work offers some practical insights for companies. The results can help them select which project to participate in and which companies to build collaboration with. The positive association between companies' collaboration degree and its productivity also offers a possible way to improve the efficiency. For open source software communities or foundations, the two-mode social network plus clustering techniques can be used to monitor and manage commercial environment, and they should pay more attention to the solo projects with only one company make contributions. Finally, I would like to summarize this presentation. What we want to address is how different companies collaborate in an open source ecosystems. And we use a mixed method of social network analysis and semantic analysis. We found 4 typical combinations of companies participating in the projects. And we characterized 3 company collaboration patterns and found a positive association between a company's collaboration degree and its developers' productivity. Our study contributes to the understanding of how different companies contribute to different projects and collaborate with each other in an open source ecosystems. Okay, thank you very much for your kind attention.